Hi guys, we're biomedic students and today we'd like to look at the facts and fiction of anti-aging products. Every once in a while a new TV commercial is broadcast promising a juice as the next panacea and the fountain of youth. From our perspective as aspiring scientists, we kinda cringe at these actually. So, let's dive straight into the matter by taking a closer look at our skin.
But before we go any further, disclaimer. Let's address the elephant in the room. Proper use of sun lotion decreases the risk of getting skin cancer, but no amount of ointment or so-called life elixir is going to extend your life by even a second. All we are discussing here is whether skincare products can improve your skin's health in a biologically attainable way.
As you may know, the skin forms our first line of defense against the elements and consists of two basic layers, the epidermis and the dermis. All the way at the bottom lies the so-called hypodermis, that connects your skin to your bones and muscles.
On top of this layer lies the dermis, made up of two distinct layers. In our lower reticular dermis you will find hair follicles, sweat glands, oily glands, heat and touch sensors, and lymph and blood vessels. Of most interest to us are the matrix components, like collagen and elastin, and give the skin its strength and elasticity. Wrinkles are a sign of the depletion of these components.
On top of our dermis lies the epidermis, separated by the basement membrane. The epidermis is commonly divided into 5 layers. You may have heard about the fact that our outer layer of skin is completely dead. This is partially true. Our skin is renewed every 48 days. Of course, these cells didn't start out that way, and the epidermis really is all about the keratinocytes. Their birth in the stratum basale and their fate as dust in the wind in the stratum corneum is a process we call cornification. Cornification starts in the stratum basale, the lowest layer of the epidermis. Here, pigment is produced that makes my colleagues white and me yellow. It is mostly made up from stem cells that produce new keratinocytes. Keratinocytes differentiate and migrate through the epidermal strata towards the outer layer of our skin, producing structural proteins that build the protective barriers of our skin. When the keratinocytes reach the stratum granulosum, they start to excrete fats and change in shape and structure. Due to being removed from blood vessels, these cells are deprived from food and oxygen and slowly die to reach the final stage of keratinocyte differentiation and become corneocytes.
The stratum corneum is the outermost layer of the epidermis, consisting of stacked corneocytes held together by proteins and various lipids that form the lamellar lipid bilayer. Each corneocyte in the stratum corneum is surrounded by a protein shell. This cell envelope repels water, and with the lamellar lipid bilayer it traps water in the stratum corneum. This not only keeps our body waterproof and our skin hydrated, but the water barrier also protects against invading microorganisms, chemical irritants, and allergens. Finally, the connections between the corneocytes dissolve, freeing them to flake off the skin.
Now, let's get into the stuff we put on our skin to try and reinvigorate it. It's important to look at 3 characteristics of these ingredients. What do they do, where do they do, and how do they get there? Let's have a look at Q10, which is an antioxidant. Antioxidants help protect our cells from big bad radicals, which are molecules that can start a rampage inside cells and damage our DNA, which is associated with aging. Q10 is one of a number of molecules capable of capturing and halting these radicals. In normal biology, this stuff is most effective at this very specific place inside cells. In order for Q10 to reach the right place, it needs to pass through a horde of dead cells. It dissolve into a living cell of the basal stratum and be transported to the right part of the cell. Well, this is not entirely impossible, it's just quite unlikely to occur on any significant scale. Q10 may be a proven effective antioxidant inside cells, but buttering your skin with this stuff just isn't gonna get enough of it where it matters the most.
Why do people feel that it works? Well, there's plenty of oils and perfumes in the ointments that make our skin feel and smell nice. And pharmaceutical companies are no dummies. You've probably heard claims like reduce the signs of aging or wrinkles seem to disappear. And to an extent, this is true. Most anti-aging creams contain water-soluble molecules that they claim will reduce wrinkles. But how? Like we said, the outer layer of the skin can retain a lot of water. When you dissolve these molecules into this water, it starts to fill up the spaces between the corneocytes, stretching and tightening the skin. What you see is a wrinkle shallowing out, but as you can imagine, as soon as you run out of the cream and these molecules are cycled out of your skin, you go back to being your wrinkly self again. It doesn't improve the health of your skin, it just fills it up to make it look that way. And just like makeup, the beauty fades fast.
However, we want to believe in a solution that will keep us young forever, and these companies know this. It's a billion-dollar industry that plays on our fear of growing old. I'm sure we all know, deep down in our wrinkly hearts, that these anti-aging creams are complete. Knowing the buildup of our skin further illustrates how unlikely it is for so-called active ingredients to reach the places they need to. And although it may make you look younger, it's only temporary and does not actually improve the skin's health. Knowing that anti-aging creams are a myth Stop wasting money at makeup, masked as medicine, and accept that someday we'll all grow old and wrinkly.
Trust science.
You're worth it.